Dear students, welcome to the next lecture on representative elements. In this lecture, we shall discuss about some compounds of xenon. First one is Cenon Difluoride XCF2. The ground state electronic configuration of xenon is krypton plus 4d10 5s2 5px2 5py2 5pz2. It has a complete octet configuration. In excited state, one of the electrons of pz orbital, 5pz orbital, gets excited to 5d orbital. And in xenon difluoride, xenon undergoes sp3d hybridisation to form 5 hybrid orbitals. Out of these 5 hybrid orbitals, 3 orbitals contain lone pairs and the 2 half-filled orbitals are used for bonding with fluorine atoms. The structure of the molecule is shown here. The 3 lone pairs lie in the equatorial trigonal fashion, and the fluorine atoms, one above the plane and one below the plane. Considering only the atoms, the molecule has a linear shape. In Cenon Tetrafluoride, the central atom xenon undergoes sp3d2 hybridization. In the excited state, 2 electrons in the 5p orbitals are excited to 2 different d orbitals. It undergoes sp3d2 hybridization to form 6 hybridized orbitals, out of which 2 hybridized orbitals contain the lone pairs and 4 half-filled hybridized orbitals are used for bonding with fluorine atoms. The structure of the molecule is shown here. It has a square planar geometry. In Cenon Hexafluoride, the excited state of xenon is as shown here. 3 electrons from the p orbitals get excited to 3 different d orbitals. And xenon undergoes sp3d3 hybridization to form 7 hybridized orbitals. One hybridized orbital contains the lone pair and the other 6 are used for bonding with fluorine atoms. All the 6 hybridized orbitals are half-filled. The structure of the molecule is as shown here. It has a distorted octahedron shape due to the presence of a lone pair of electron. Next comes Cenon Trioxide, in which 3 electrons of the p orbitals, 5p orbitals, are excited to 3 different d orbitals. Cenon undergoes sp3 hybridization to form 4 hybridized orbitals. One contains the lone pair and the other 3 half-filled hybridized orbitals are used for sigma bond formation with oxygen atoms. The unhybridized orbitals containing unpaired electrons form the pi bonds with oxygens. The structure of the molecule is pyramidal. Next one is Cenon Tetroxide. Here, the excited state electronic configuration of xenon is krypton plus 4d10, 5s1, 5px1, 5py1, 5pz1, 5dxy1, 5dyz1, 5dxz1, 5dx square minus y square 1. And xenon undergoes sp3 hybridization to form 4 hybridized orbitals which are half-filled. There are 4 unhybridized half-filled orbitals too. The hybridized half-filled orbitals overlaps with oxygens to form the sigma bonds, and the unhybridized half-filled orbitals overlap with oxygens to form the pi bonds. The structure of the molecule is tetrahedral. Next comes Cenon oxofluorides, and the first one is Cenon Difluoride XEO4. Here in the excited state of xenon, 2 p electrons are excited to d orbitals. Xenon undergoes sp3 dehybridization to form 5 hybridized orbitals, out of which 2 hybridized orbitals contain the lone pairs and the other 3 hybridized half-filled orbitals are used for sigma bond formation. There are 2 xenon fluorine bonds and 1 xenon oxygen sigma bond. The unhybridized half-filled d orbital of xenon overlaps with oxygen to form the pi bond. And thus xenon forms a double bond with oxygen. The structure of the molecule is T-shaped. Next is XEO4. In this molecule, 3 p electrons are excited to d orbitals, and xenon undergoes sp3d2 hybridization to form 6 hybridized orbitals. Out of these 6 hybridized orbitals, one of the orbitals contains the lone pair of electrons. And other 5 half-filled hybridized orbitals are used for sigma bond formation. There are 4 xenon fluorine sigma bonds and 1 xenon oxygen sigma bond. The unhybridized d orbital, which is half-filled, overlaps with the 2p orbital of oxygen to form the pi bond. The structure of the molecule is square pyramidal. Next compound is XEO2F2. Here xenon undergoes sp3d hybridization to form 5 hybridized orbitals, out of which one contains the lone pair. The other 4 half-filled hybridized orbitals are used for the sigma bond formation. 2 xenon fluorine sigma bonds and 2 xenon oxygen sigma bonds. The unhybridized half-filled d orbitals form pi bonds with the 2 oxygen atoms. The molecule has a seesaw shape. Next is Cenon O2 F4. Here the central molecule xenon undergoes sp3d2 hybridization and forms 6 hybridized orbitals. All the 6 hybridized orbitals are half-filled. 4 of them forms xenon fluorine sigma bonds and 2 form xenon oxygen sigma bonds. 2 unhybridized half-filled d orbitals of xenon form the pi bonds with the 2 oxygen atoms. The structure of the molecule is octahedral with xenon and fluorine atoms lying in the same plane and the oxygen atoms lying one above and one below the plane. And another compound is XEO3F2. Here the hybridization is sp3d. Xenon forms 5 hybridized orbitals which are half-filled, out of which 2 are used for xenon fluorine sigma bonds and 3 for xenon oxygen sigma bonds. The unhybridized 5d orbitals of xenon, which is half-filled, form pi bonds with 3 oxygen atoms. Xenon and 3 oxygens lie in the same plane in trigonal fashion, and the fluorine atoms lie one above the plane and one below the plane. The structure of the molecule is trigonal bipyramidal.